Okay.
Hoonigan.
Hoonigan? How did you get in touch? They just called you, hey, Dimitri, build me a nice car? Or?
No, so the concept of the car we've been working on, and then our partner Scarborough Performance actually conceptualized the thing. Like, he started thinking about it 10 years ago. Some radical...
10 years ago?
Yeah, like he bought like I think a early 911, and he was like, well, how can I turn this up, right? And so first it started out, I was like, well, we're going to put something, 996 driveline inside this air-cooled car. So take something like that shell and put a 996 driveline in it. And then at some point in the conversation, the Tim got involved, we're like, and then the car became wider, bigger, and at some point we're like, well, it'd be kind of cool. We built so many cars based on the 991 GT3 and 997 GT3 with Sport. We built really cool Pikes Peak cars based on the existing chassis. And did pretty well with those. We ran the GT2 RS Club Sport with Donahue. We ran Raphael Astier and Lucy, the Cup car. We widened it, lightened it. We did everything. And then at some point we ran out of chassis, right? Like, what is the next thing? Mm-hmm. The next thing is like, well, we can either keep hacking up like a car like this, or we build our own stuff. So then this was the result. We're like, all right, let's build this. And we approached Hoonigan and be like, what do you guys think about like doing something like this? Because they were crazy enough to try this, or to even, they're like the people who would, right? And they're like, oh, I don't know. And so then we're like, well, Ken wanted to drive at Pikes Peak. And they're like, hold on, come back. He wants to drive, and then it went crazy from then.
Okay.
So we started in January. This car in like 2022, maybe December 2021, just sketches, right? And then by May we had a full car.
Okay, that's really crazy to get the whole project done in 5 months.
It's crazy. Yeah.
What's left? Is any left stock here? Anything or?
So
maybe you can give us a tour.
The only factory part is the roof.
Okay.
That we should replace to make it lighter, and then the doors are factory. They're not a factory door, but it's the same shape. Yeah. Right. Direct replacement.
Okay, so the ground chassis was a, what is it? A 964?
There is no
nothing. So
this is the ground chassis. Right? This is the foundation of it.
And the optics are related to.
It's supposed to be, the car was like a 68 911.
Okay.
But it's supposed to look like a early 70s.
Yeah, that's an early 70F model. Looks like
long hood,
this. Long hood, yes.
First of all, we found out exactly how small these cars are, right?
Yes.
When you start putting a twin turbo GT3R engine into it, it's a really small car. So you can see how narrow it is when you're sitting in it. The seat comes up over the middle of the car in its width. So you can see how narrow the cabin is. Everything's super tight. And then we started working on the visuals. We got with the oil stain guys. We're doing that half 11 concept, and we started like, how do we keep the essence of an early car, but make sure it also doesn't look awesome? Because putting giant flares on either side is a whole other thing, and it can really mess it up. So everything is massaged a little bit here and there, because again, there's no sheet metal underneath it. We're not constrained by anything.
Okay.
And then the cool thing about like somebody like us and Pikes Peak is that we're not an OEM, so we don't have to be Peugeot or Volkswagen and constrained to a modern body style, we can do whatever we want.
Yes, exactly.
We want to make a Volkswagen Beetle, with crazy aero, we could, so this is actually a glorified Beetle, right, in a way.
So maybe, can you give us a tour about the techniques, or, some details, what's special here, or... Everything's special.
Well, I think the whole car is special.
Okay.
So, basic numbers is like 1,400 horsepower, all-wheel drive, sequential.
Where's the engine? The engine is not...
It's a mid-engine configuration.
Okay.
Do you know the depth of the pressure?
Yeah, so the whole car generates 5,000 pounds of downforce at 180 miles an hour.
Okay.
And we can configure it to be a little less and a little more depending on what's needed. We don't hit 180 miles an hour on the hill. I think it's up to like 168. But it could drive in the tunnel upside down, technically.
Okay.
On paper. Okay. Not yet tested.
I think that's 99.
meinte er vorhin mit, wenn die Autos ein bisschen zu laut sind. Nur ein bisschen. So the axle is what the no car is it? It's
So
cup car.
the whole suspension system is custom, but we didn't, reinvent the wheel when we don't need to. So this is a cup car center lock and hub. It's rotors from what is typically would be on a GT4 Cup Sport, but it's a carbon ceramic that we got out of UK. The PFC calipers are from a GT3R, but the uprights and then the rest of the suspension is all bespoke. So
Okay.
we were working with PFC. PFC have tested that rotor, and then they have a pad compound to work with that rotor. One of the things that we found with Pikes Peak was, there's no warm-up laps. So you have to have 100% brake performance at the starting line, and that's, in motorsport that doesn't happen, right? There's always like a couple of warm-up laps, get heat in your brakes, and then PFC's like, yeah, just put some heat in your brakes. I'm like, when? We're going, right? Like you pull up, the car has, we warm up the engine. That's about the only thing that gets warmed up, right? And so we keep the tires in an oven before the race. So like when we're supposed to go, like 5 seconds before, we'll pull them out. They're all hot and then put them, on the car, and they actually lose temperature as they go up. And then, the brakes are cold, everything's cold. So the biggest challenge is getting this combination. We've perfected that over the years.
Okay, so at the rear, this is the attachment for the spoiler, right?
Yes. So we use the transmission as a stress member. It's part of the structure of the car. So the spoiler, the whole rear wing assembly attaches to the transmission, which attaches to the main chassis. The engine goes here. That big belt housing back there is also part of the suspension setup and the kind of chassis reinforcement. Okay. So you kind of like pull a pin and the whole thing just falls apart.
Okay, so the chassis is attached to this massive CNC
Yeah, that's
car.
the belt housing adapter. It goes from the engine to the transmission. This is built like a Daytona prototype, a Le Mans car, and very similar. A little more metal for safety, but and rigidity, but it's very similar. Push rod suspension.
It looks like rocket science to me. It looks super complicated. Would you say it's super complicated, or is it just maybe it's easier because you can do what you want? Like
I think it's complicated in that it's modular, and then we wanted to program more tunability in it. So there are a little more parts than you would find in a regular car, but the regular car just packages it in a more OEM manner. This is just motorsport. So if you crack open any R18 or 919 race car, this is getting there. Not those are complicated. This is somewhere in between 919 and a street car.
And the shaft going over the
so
engine.
Engine, transmission, transfer case.
Yes.
And then this goes to the front. So it goes over the engine in between the banks because it's a flat six.
This is just because of the room you have left, so there's no other solution.
Yeah, traditionally on V engines, there's a room around the side of the engine to go.
Yes.
Flat six, there is no room. So either we jack the engine up and raise the center of gravity, or we slam everything down as low as it can be. The lowest point on the car is just below like the engine oil pan.
Okay.
So everything is super, super low, super dialed in.
Does it have any disadvantages to do it this way, or is it the best?
This is the only way.
The only way, okay.
For something like this, for a mid-engine flat six configuration, I don't really see any other way without getting creative of trying to drive something through the engine. This is probably the best possible packaging within a 5-month time frame that we could come up with.
And the gearbox is it from Porsche, or is it?
No, it's a French company, seht.
Okay.
It's actually very similar to the gearbox on the Hoonipigasus Ken Block's Mustang. It's widely used by rally teams, and it's just very robust.
Do you know what they can handle on power?
Well, clearly handles 1,400 horsepower. But they build gearboxes for like Dakar cars and a lot of others, so power is not really a challenge for them.
Okay.
We like seht because it's the shifting mechanism. It's a hydraulic shifter. It's super fast and very reliable, and then the gearbox is compact yet robust, and it's just a great company to work with.
I have to ask some stupid questions. I'm sorry, but how many gears do you have on this?
6.
6. Oh,
Yeah.
6. Okay, and the ratio is like, could I drive this on the street, or is it really meant?
Hurry now.
No, it's so because the Pikes Peak has very slow corners, the gear ratio has to be closer to what you would think on the street. The car itself is like not street drivable, but it's the gear ratios make it so that you can go through a first gear hairpin at Pikes Peak, which is a very slow corner, and there's like 7 of them. So we can't gear it to be like a race car where it's all in the high end. We have to be conscious of the low speeds as well.
Okay.
But yeah, engine in the middle. The driver sits on the other side of this gold foil.
Let's take a look at the inside.
This is the fuel tank. So this is your 20 liters of methanol, and this you sit right next to it.
And Ken drove this.
Yes.
Okay. This year at Pikes Peak.
This year at Pikes Peak, but we didn't make it to the race because we had engine trouble.
Mm-hmm.
So we had to withdraw early, and we've been working on it since, trying to get it together.
Yeah, that's how it works, right? I mean
that's racing,
that's
right? You sometimes you go up and then you do well, and sometimes you go up and then you break something.
It looks so sad.
Yeah, that's
stones overall. Okay, and that's I mean, the rest of it is just regular race technique, or
I mean, it's loaded with all the safety stuff. You know, we have fire suppression system. The one thing you can't see in the back, but you can kind of see up front is, you know, more suspension set up. So we have the inboard suspension.
That's a push rod system, right?
Yeah, it's push rod front and rear.
Wow.
But it does have we have one more trick on this thing. It's active ride height.
Okay.
So not only it's, you know, push rod like standard geometry for a race car, the car can adjust its ride height. So in real time, it compensates for aero loads, so high speeds when the car is getting pushed down. It has laser ride height sensors where it compensates and raises it up a little bit.
Okay.
Not very many conditions that happens in, but the biggest thing is that it raises its target height as it goes up the hill because it gets bumpier. Yes. So we need more ground clearance to save the aero. So we have a GPS unit in the car that tracks its position, and as it's going up the mountain, it's raising its height.
I love that stuff. That's crazy. But how do you do it? How do you lift?
Yeah,
the
so
car?
there's
what do you?
We have the standard suspension, and then in the middle we have these hydraulic rams front and back.
Yeah, I see.
And then a solenoid to drive them. So the hydraulic system, we have two power steering pumps, for example. One's for the power steering, and the other one's for the hydraulic system for the active ride height. So when needed, the rams essentially it changes the position of the shock mount, so it changes the ride height. So the travel of all the shocks and everything stays the same, just at a different ride height.
Wow, that's.
Another cool thing about Pikes Peak is you can do that. It's not illegal. You know, you can get creative with
Is there
like
a specific FIA or regulation sheet for Pikes Peak? What you can do, what not?
Yeah. So depending on the class you're on, the biggest thing is safety for them.
Okay.
Right. So you have to make sure that all of this is up to snuff. You have the fire suppression. You have everything safe. The next thing is, depending on the class you run, you can or can't modify certain things. But when you get to open class, which is what this was in, or unlimited, there's not very many limitations, right? Okay. And then not very many limitations like otherwise you would have even in Le Mans or something, right? Where in like the real race leagues, like you can't have active this or that, you know. So we can, because it's a good experimentation test bed, you know. For that.
Okay, then maybe ganz kurz. Also diese Bremse, ne? I just said these brake calipers are so huge.
Oh, they're beautiful. Yeah. My favorite part. And they're so light and small too. Like they're not small, but they're light. Yeah. And they're pretty compact for what they deliver.
The engine you have.
Yeah, it shows. So this is the engine building room.
Yeah.
But this is the Pikes Peak engine. So the engine in this car is out of like a 2018 GT3R. The GT3R has really nice cams. It has really nice big ports. And it's just a really good package overall. But we upgrade the internals, so we have nice upgraded rods, pistons, bearings, studs to make this thing hold together 1,400 horsepower.
GT3R, right?
Yes.
Okay, and this is what series? Like 991 or?
991.
It's in German?
No, it's a Porsche factory race.
Yeah. In Germany, with 24 hours Nürburgring.
But it is 991. 991 GT3.
Yeah.
Okay.
That's it's
the chassis.
Now the 992R is now
that just
released.
Came out, yeah.
It's the test. Mantai drives this engine.
This is the Grello.
Yeah.
Okay.
That's the basic engine of the Grello.
Wow. What's the price for such an engine?
For a GT3R engine, I actually don't know because
it's so not expensive. Like, you don't know.
Yeah, it's like
okay.
You have to have the car. You have to have a race team before they even sell you one part.
Really?
Yeah. You only can buy parts
If you're
if you have a VIN number.
Yeah.
Okay.
If you don't have, you have a parts catalog only if you have a VIN number.
Okay, but so you bought a car?
No,
for this
we were very fortunate to have a good relationship with Porsche Motorsport in North America. So
that's always good to have.
yeah, so they came in and helped us with some of this stuff. There's only 3 guys in the world that are allowed to work on GT3R engines, and one of them is here. So not a BBI, but a Porsche Motorsport. So
Okay.
yeah, that's the cool thing. I mean, just large ports.
And you just changed the internals, and how about
Internals, we balance them a little better. We changed some stuff on the valve train, bearings, and that's kind of it. It has really good oil pumps. It has really good everything else, cooling. You know, we used a factory direct injection system, but then we add 2 more injectors per port, so there's 3 injectors per port because of the methanol system. We run the DI system. We also run the secondary port fuel system.
Okay.
And then we have our own control system, so we use Motec for controlling the engine. We actually have 2 ECUs in that car. There's one for the engine and one for the chassis control.
Okay.
But we also, these things that they run with a very small, very lightweight alternator, which is really nice. We like Porsches because they're a really good foundation. The better the starting point, the further ahead you are when you're modifying it. So like with all the Metzgers or the other cars, they last because they're really good to begin with.
Yes. Just one question before. Okay. Sorry. The combustion ratio is stock. Do you know what's the?
No. I think it's stock to
like stock
to the R. Yeah. Okay. So I think 13-1 or maybe 13-1. Yeah.
And like this first.
Next stupid question, but this is NA or turbocharged on this car?
It's twin turbo.
It's twin turbocharged, right? Because it wouldn't be Ken Block if it's NA, right?
No, I can't make 1400 horsepower.
Yes, exactly. That's crazy ratio for a twin turbo power
car.
Right?
That's what I say.
Did anyone else a turbo conversion in this engine?
Not this engine. No.
Okay.
We have this engine, and we have a customer project, that car in the showroom. That's also, but that one's based on the GT3 engine, but all the same generation. But I don't know anybody who's properly turbocharged them and sustained them. Yeah.
But the engine wasn't the issue at the race.
No, so we dropped the valve, and then I think it's one of these actually. Not this one, but we dropped one of these valves. It popped out, and it got smashed up
during the race, or
it was during one of the practice sessions.
Oh, okay.
So
it was a material.
These are just used.
Okay.
It was I think a mix of things. There was a high rep condition and. Just kind of a perfect storm of issues where something failed, it dropped out.
Yeah.
We've kind of went over everything, all of the data logs, and we've adjusted a lot. So this is kind of the 3rd variant of that, and so I think that'll be the bulletproof version. There's a lot of changes, a lot of small changes on that engine.
The 3rd engine?
No, third
version
of that, yeah.
Okay.
Because we built the first one, that blew up, we rebuilt it. A lot of the components were good. So, we just needed a new head on one side and a new block. So we rebuilt everything, put it back together. We went out testing. We heard another noise. We shut it down before anything happened, but it confirmed some of our concerns, and then we went and we addressed them. Now that one's that should be 99% perfect.
Okay.
So this is exhaust manifold. It's made out of 3D printed Inconel.
3D printed.
Yeah. So 1 millimeter wall thickness. Pretty light for an exhaust manifold.
Oh yeah.
And then the cool thing about this is they came kind of late, but one of our partners is Autodesk, and they have Fusion 360, which I use for.
It sounds like you have really good partners.
Yeah. So I use their 3D design software to do a lot of the engine stuff, and but this header design was a result of using essentially AI to draw out the runners in the ideal configuration. So I know the exhaust flow parameters, and I know the starting point and an end point, here. And so then I tell the software, you go from here to here and draw me the best tube, right? And then it'll draw you something that'll reduce pressure drop.
I have to translate this because this is real. That's like rocket science, right?
Nerdy thing.
Yeah, that's really nice. was er gerade, also nochmal für die es nicht verstanden haben, was er gesagt hat, ist, diese Rohrführung ist, also hat der Computer gemacht, ja, das ist halt AI und er weiß halt, wie der Abgasstrom ist, wie das Volumen ist und die Software berechnet einfach automatisch, wie das Rohrdesign zu sein hat, damit es den perfekten Flow hat. But you don't use the Porsche stock computer
No,
anything.
because this is so far beyond, it's easier to go your own.
Okay.
So we built our own, Obsidian Engineering put together the whole Motec and wiring package for this thing. Okay. So this is the intake manifold on one of the intake manifolds.
This is art. I would place this in my living room.
So 3D printed aluminum with a 5-axis machine base, and then you can see so this car runs 3 injectors per port. So you got the DI injector from the factory system, and then you have 2 more injectors because methanol requires so much fuel.
Okay. What cubic?
I think these are like IG like 2050s. Yeah, each.
That's a lot. I mean, twice of them, and
So it's a lot of fuel plus the DI.
yeah.
system.
Look at the at the rail here.
So here it was more for volume to make sure that when these are all open, that you don't empty the rail. And we have 4 very capable fuel pumps.
Is it heavy? Can I? No, not heavy. Not heavy at all.
Printing is cool because it's a big volume. You can't, and this is you can keep it thin.
You do it close to here, or
No, a company in Austria, Penkel, does it.
in Austria?
Yeah.
Oh, really?
So Penkel makes all the titanium.
You know them?
No.
Okay. Okay.
But
I
think we could.
I think
You
it's
should look them up.
Yes.
They do a few things in the car.
What was the name?
Penkel.
okay. I think it will be very expensive, but
It's
or isn't it?
I think for price is relative to the application, right? So if I were to sell this to Volkswagen owners, no, I mean it's probably price of their engine, but and it isn't. It's not that expensive for the benefit that you get out of it.
Yes.
Because to make this, either you machine it and weld it together, but it's still a lot of wasted material. So printing this is the most elegant, best way to achieve this shape.
Okay.
I didn't print this because there's a lot of specific machined elements. So if you were to print it, you'd have to go back in and machine it. So that's why I separated it out. I said I'm just going to machine this part.
Separate.
And then merge were lower tolerance and high tolerance areas, and then kind of mix and match between the two.
Makes sense.
Same thing with the headers, I don't need to print in flanges and figure out how to machine it, I would just machine flanges separate and then weld them together. Unfortunately, you have to weld these together too because of printing orientation and things like that, but
Yes.
just being smart about, where you use technology and to which point,
And this is what you do here, right? I mean, you just create these parts and how you produce them.
Da ist die Turbo, die Abgasanlage ja schon fast langweilig.
Exactly. What he said is the exhaust system is like the not the fanciest one, right? I mean, it's just straight.
We're just it's just keeping it light and simple. It's pretty much get it in here as quickly as possible and get it out of there as quickly as possible.
Yes. What turbo is it?
Property similar to a G35 1070 or whatever that part number is, but this is actually out of Garrett Motorsport.
Okay.
If this wasn't assembled, it's I think each turbo is just over 9 kilograms.
Wow.
Super, super lightweight. Just very lightweight aluminum center, stainless housing, and then just...
This one looks not that big, right?
No.
It's not that big, but it's very powerful, yeah.
So, complete bearing? Ceramic bearing or?
It is ceramic. There's no water cooling. It's just...
Okay.
But it's a special... This is like the largest Garrett Motorsport, so the largest turbocharger they made for a customer outside an F1.
How expensive?
Sub 10K.
Okay. For each.
Yeah.
Okay. And did you change anything here, like make a bigger compression wheel here, or
they're pretty much putting the biggest compressor wheel on this size, so the space is a constraint, So this cartridge.
This is locked, right? We can't take a look at. Or is it open?
It's not that big, but it's very efficient.
Okay.
And it's just specifically made for this application. But this is the biggest wheel they can fit on this cartridge because people always try to put big wheels on smart cartridges, and there's a lot of, when you're spinning them to 130,000 RPM. There's a lot of load, you know, so Garrett is pretty adamant on making sure that they're balancing the size of the wheel to the shaft to the cartridge so it can sustain the abuse, because not only is it spinning, there's also anti-lag and other things.
What's the what RPMs are you driving with this engine? Because it's basically it's an A engine, so it can rev very high, right?
Correct. We cap it at 9,000.
Okay.
Let's see.
Okay.
The cams and everything are really good, and it's designed as an NA engine. We're just taking advantage of it. So just like with the high compression, we just are really careful with control system, right? A lot of people drop the compression because it gives you a larger margin of error, you know? You have to run more boost, and it's like, and so when it's tighter, everything is more sensitive.
20 years ago, you would do a lower compression, but today with this weld frame and the camshaft and all the things and ignitions and all, yes, you can drop some
the sensors and the speed, the data logging, everything is much better. So this is also in-canal 3D printed exhaust tips that the exhaust comes out.
That was necessary, or that's just for you can do it?
Because I wanted to.
Got it.
Yeah, so I guess this is the only other original part of the car. So this is the quarter panel, but then this is all carbon added on top of it.
And that's the side skirt, oh?
And this is the rear quarter panel.
Can I maybe lift?
Yeah.
Okay. Yeah.
Not much to it.
Yes.
The steel is the heavy
Yes,
part.
I thought it's
it's original.
This is Porsche original.
yes. Okay.
Just because the door is really pain in the ass to frame in, so why recreate that, you know?
Yeah.
And we wanted the lines to maintain.
Okay, Dimitri, thanks a lot for your
Thank
time
you.
having us here, and maybe we will see at SEMA.
Yeah, that'd be awesome.
Okay.